Good morning, Shubh, Abhishek, Asha. So let us wait for 2 or 3 minutes and then we'll start this lecture. Very good morning, Abhishek. Welcome, Parita. Welcome, Reshma. Okay, so good morning, all of you, and welcome. And I hope that most of you have joined. So we can start the lecture now. Very good morning, Shivani. Good morning, all of you. Okay, so let us start the lecture now. I'm sharing the screen. So in the previous lecture, we had seen basic things about data warehouse. We had seen the definition, we had seen the basic difference between database, data warehouse, and in definition, there are four terms: integrated, subject-oriented, non-volatile, and time variant. These four words we had discussed. So we had seen this basic definition and the four words, or you can say the four characteristics of data warehouse. We had also seen these difference between database, data warehouse, as well as OLTP and OLAP. And so in the previous session, we had seen up to this, right, all of you? Right? In the previous lecture, we had seen up to these differences. Okay, thank you so much for the response, Parita. Great, it's fine. So now we will discuss ahead. Now in today's session, what we will discuss? Okay, just a minute, please wait for a while, all of you. Okay, am I able to all? Thank you for the response. Thank you, Vani. Fine. Right now let us see what we are going to see today. So we have seen all kind of differences. Now we have discussed about data warehouse also. So about data warehouse, like if you want to store data, then as we have discussed that is historical data, right? So here with respect to data warehouse, if you want to create data warehouse, then you need some design. Like in database, you need ER diagrams. Based on ER diagrams, you are going to create database. Same way, to create data warehouse, you need some diagrams or you need some schemas. Here with respect to data warehouse, it is schemas, whereas in database it is ER diagrams and all. Right, so we will see ER diagram. Schemas. Schemas are, you can say, that the basic designs which will be helpful for creating data warehouses. As well as we will also see that here, whenever you are going to store data inside data warehouse, excuse me, if you store data in data warehouse and whenever you are trying to do some kind of analysis and all, then you need the data in multi-dimensional format. So how it is possible? So we will also see that if you want to have analysis, if you want to have reporting and that kind of thing from data warehouse, that is the main aim, that is the main goal, then how you can get the data in multi-dimensional format. Right, so these things we'll discuss in this lecture. So we'll see the multi-dimensional data model. So here data warehouse is based on multi-dimensional data model, because what will happen, okay, let me just say. Because I hope it is visible to all. Okay, so for example, this is your data warehouse. And here is your tool from where you want to generate the analysis. Excuse me. And to deal between these two things, data warehouse data and the tool, data warehousing tool, you can say, there will be a data warehousing system to connect these two. Or you can call it data warehouse management system. So here, what this data warehousing or data warehouse management system will do, it is going to fetch the data from data warehouse. Let us say you want some analysis. So what you will do, you will fire a query. You will generate a query. Now, what this data warehouse management system will do, from data warehouse, let us say this is data warehouse. in between this data warehouse management system, this warehouse management system is going to generate cubes, or you can say that data in multiple dimensions. And from this multiple dimensional data, it is going to fetch the result. So again, it is going to send the query. Excuse me. And based on that query, this kind of multi-dimensional data will be generated, and you will get the proper analysis or reporting. And then you can generate the report or analysis that you want. So this is the basic system, you can say. This same thing we'll discuss ahead in detail. This is just to overview that how this multidimensional data will be useful. So let me share the PPT again. Okay, so our data warehouse is based on multidimensional data model, which views the data in the form of data cubes. So that we have already discussed. Data cubes such as sales. How the sales can be, let us say you are in sale data. You are having data of sales for any company. So you can have, or you can separate that data with respect to multiple dimensions. Right? So you can say that you can have the data in sales. You can have the data of item, you can have the data of time, and other things. Right? So here, multiple dimensions or dimension tables can be there. Let us say dimension table of item can be there, which can store item name, brand, type. You can have dimension tables like time, which can store the data of day in terms of week, in terms of month, quarter, year. Fine. And here fact table will be there. There is a concept of fact table. So fact table is a kind of central entity where you're going to store keys. How it is possible, that we'll see next slide. And please focus on data warehousing. You are having a concept of cubes, as we know, and here any multiple data. Fine. So here, let us say you are having a kind of multi-dimensional data with highest direct dimensions. Let us say 4D or 5D, 7D. 7D in the sense what? That in that cube, in the cuboid of 10 dimensions. That means what? You are going to include 10 dimensional tables or 10 dimension tables. Fine. So how it is possible, or what is it? All the things we'll see later in the upcoming slide. But here just focus on these two words. That is the base cuboid and apex cuboid. Now, what is base cuboid? This kind of question can be asked. What is base cuboid? What is apex cuboid? Or with the dimension of base cuboid, what will be the dimensions of apex cuboid? This kind of question can be there in MCQ or short answer question. So base cuboid, let us say you are having, from data you can generate the cuboid with highest dimensions, or and the highest dimension is, let us say, 7. You cannot generate cuboid more than 7 dimensions. So what you can say, that 7D base cuboid or 7D cuboid is the cuboid which is having highest dimensions, and 7 is the dimension of your base cuboid. Fine. So 7D cuboid is your base cuboid because it is having highest dimension. Now, what is apex cuboid? Apex cuboid means the cuboid with zero dimension. You are not going to separate any data with respect to any dimensions. So that is your apex cuboid. And so let us try to understand this concept of multi-dimensional data. Here, by considering this each lattices, you can consider it as individual cuboids. So let us try to understand the concept of this cuboid, lattices, and so this here you are having, or you are going to save all data. You are not going to separate any data. Let us say if you are having data of item, time, location, sales, cost, supplier, customer, all the data will be there at this place. That's why it is all. And this is the lattice or cuboid with zero dimensions, because we are not considering any dimension here. Right? That is why it is 0D cuboid. And as it is having no dimensions or zero dimensions, it is called apex cuboid. Now, just assume that here in this all data, you are going to have all possible data inside it, like data of customers, data of items, data of location, data of supply, data of time, data of, let us say, departments and all. So it is up to you, it is up to your analysis that which dimensions you want to consider for analysis. Let us say out of 15 dimensions, I'm considering this 4 dimension for my analysis. Which 4? Time, item, location, and supplier. Right, so what I'm doing, I'm separating data with respect to these entities. So here from all data, I'm going to separate the data of time, I'm going to separate the data of item, location, supply. Right, so this you can call as individual dimensions or single dimension, or you can consider all this as 1D cuboids because it is only having one dimension. Sorry, it was Wi-Fi issue is there, and I'm audible to all. Okay, so we were discussing here, you are separating the data from all data with respect to these dimensions like item, time, location, supply. Fine. So here you are having one dimensions only. So what you are doing here, you are separating the data with respect to these entities. Like here you will only find the data of time. Here you will only find the data of item. Here you are only to find the data of location, and here the data will be supplier will be there. Only supplier. Sorry again, this was a kind of Wi-Fi issue. Because I hope that you all can see the screen and my voice is audible. Okay, so we are discussing this 1D cuboid. Now, from this 1D cuboid, you can have the combination of individual dimensions, that this 1D dimensions. Excuse me. Like what you can do, you can combine, let us say, time item, you can combine time location, you can combine location supplier, you can combine item supplier, and you can generate lattices with 2 dimensions, and all those considered as 2D cuboids. Now, it was easy that you are having 1 dimensions lattices, and now you are going to consider combination of 2. Now, from 2D dimensions or 2D cuboids, you want to create 3D cuboid. So how it will be possible? So for that, excuse me. For that, what you can do, you can consider this time item, time location. Now, in these 2 lattices, time is common. Fine, so consider these 2 lattices, and you can come. So you will have the lattice with 3 dimensions. With 3 dimensions, time, item, location. Now here, in these 2 lattices, let us say time supplier, item supplier. Supplier is common, so you again combine these 2, and you can create time, supplier, item. The cuboid with 3 dimensions, these 3 dimensions. Then here, item, location, supplier. Here you are having location as common dimension, so you can create 3D cuboid or 3D lattice with the dimension item, location, and supplier. So 3D cuboids. Now, from this 3D cuboid, can you create more cuboid with 4 dimension? Because we have created 0 dimension, 1 dimension, 3 dimension cuboid. Now from 1 to 3 dimension cuboid, can you generate 4D cuboid? So for that, you need to consider, let us say, for example, we are considering these 2 lattices with time, item, location, time, item, supplier. So here, as you can have common 2 dimensions, which 2 dimensions? Time, item, time, item. These 2 dimensions are common. So you can again combine these 2, and you can create 4D cuboid with time, item, location, and supplier. Fine. Now, just assume that here you are having time, item, supplier, time, location, supplier. If you again combine these 2, you will have same 4D cuboid, which will again have same 4D cuboid, same dimensions like time, item, location, supplier. Fine. So if you combine any of these 4 3D cuboids, you will find, or you will create this only single 4D cuboid with these dimensions, time, item, location, supplier. Okay, now can you create 5D cuboid based on this 4D cuboid? Question to all. Can you create 5D cuboid based on this 4D cuboid? No. Exactly. Thank you so much, Ruthik, for the answer. We cannot create. Why? Because further combination is not possible, as well as other 4D cuboid is also not available. Fine. So you can simply say that here the maximum dimensional cuboid is 4D cuboid, and as it is having the highest or maximum number of dimensions, it is called base cuboid. So here you cannot consider 1D as base cuboid, you cannot consider 2D as base cuboid, you cannot consider 3D as base cuboid. You can say that 4D is base cuboid because it is having the highest dimensions. That's why it is called base cuboid. You can say that here, with respect to this topic, at this point, here ND is your base cuboid or base cube. So here, what is the dimension of N here for base cuboid? N is equal to 4. or you can say that n equal to 4, or 4 is the maximum dimensions of your base cuboid. And what is the dimension for apex cuboid? That is 0. And that is the concept of cuboid lattices and apex cuboid, base cuboid. Okay, now as you have already studied in your database management system subject, DBMS subject, that if you want to create database, you want to have ER diagrams. So based on ER diagrams, you can create database. You can have now in your those ER diagrams and all key foreign key concepts to link those tables. Now same way, if you want to create data warehouse, then you need schemas. What is schema? Design, you can say basic designs for creating schemas, or basic designs for creating data warehouse. So here you are having 3 types of schemas: star schema, snowflake schema, fact constellation schema, or galaxy schema. Both are same. So here fact constellation schema as well as galaxy schema, both are same. Now why these schemas are known as, let's say, star schema, snowflake schema, galaxy schema? Because of its structure. Fine, so we all know what is the structure of star. Fine, so let us see the structure of star, galaxy, and the snowflake. Okay, so this is the example of star schema. What is a schema? Again, getting this point that as you are having ER diagrams and all for creating databases, same way to create a warehouse. You are, you can say that this is level of sales. Already discussed here that here you are having all data. Here you can divide all data into multiple dimensions. Excuse me. Fine. So, and you can also say that in sales you can have the data of item, time, customer, and all. So in star schema, at the center you are having the fact table. This is example of sales. So at the center you are having fact table. Now what is fact table? Fact table is a table which is going to contain, or which is consist of keys which are going to link your fact table with dimensional table. So item, time, branch, location, all these are dimension tables. Dimension table like what? Like let us say, for example, time is a one dimension, item is one dimension, location is one dimension. So here these are those dimensional tables for those dimensions, and inside that you are also having same key. Let us say here you are having time key. So you, in time dimensional table, you are also going to include time key, because with the help of this key you can fetch the data of time from this fact table, and you can also have the data of, let us say, day of the week, month, quarter, year. Then this is item key. So as you can see that here in the fact table you are having all the type of keys, or all the keys for different dimension tables. Fine. So here you are having item key. The same key is going to be included in this dimension table item. That is item key you are having here. So what you can do with this fact table? With the help of this item key, you can fetch the data of items. Fine. So along with item key, you are also having item name, brand, type, cost, and all, along with inside this dimension table item. Location key is going to point out to this location dimension table. Branch key is going to point down to this branch dimension table. Now, along with this keys, you are also going to have some kind of common data, like number of units sold for that sales or analysis, then dollars sold, how much dollars of sales you have made, then average sales. So that kind of common information you can also store inside this fact table. Now, why it is star schema? Because at the center you are having fact table, and around it you are having this dimension table. So it is kind of structure like star. That's why it is called star schema. Now let me again explain that part. Okay, so here let us at the center you are having fact table, and around it with fact table, different dimensional tables are connected. Structure like star, it is called star schema. Now let us switch to the next schema. The next schema is snowflake schema. Why it is called snowflake? Because it is similar to the snowflake. Fine, so we will see the snowflake. For example, what is snowflake? So for example, you are having fact table here. What is fact table that we have discussed? Now inside fact table you are having dimension keys. Those keys are going to point out to the dimension tables, the same keys. So here in star, whereas in the snowflake, what you are doing, you are extending that dimension table. Right, so this is item dimension table. Here you are going to include supplier key, which is going to point out or link to this supplier dimension. Fine, so this table, this is dimension table. Dimension table is again going to extend or going to link to this other dimension table, that is supplier. Right, so here what you are doing, you are extending the dimension tables. So in location you are having city key. City key is going to point out to this city dimension table, where you are having the data of, let us say, city, state, country, along with city key. Here you are having primary key, supplier key. Right, so you are extending these dimension tables, and it is the structure like snowflake. It is called snowflake schema. Now let us see the structure of snowflake. You can clearly get idea that why it is called snowflake. This we had having fact table, and what you are doing, let's say here you are having this fact table will be linked with dimension tables. Now these are the dimension tables. This is the star schema. Now in Snowflake schema, what will happen? You are again going to extend these dimension tables. You are going to extend it and going to link with other dimension tables. Again, it is not possible. It is not necessary that all these dimension tables will extend or should be extended. Some dimension tables will extend. You can extend further. It is up to the requirement. You can extend some dimension tables. Some cannot be extended. Right? So it is up to the requirement. Right? So as it is the kind of structure like Snowflake, it is called Snowflake schema. Now let us see the image of Snowflake so that you can have a clear idea. So as you can see on the screen, that these are the images of Snowflake, and at the center here we are having fact table. Fact tables are connected with dimension tables, and you are again extending those fact tables. Sorry, dimension tables. The fact table at the center, dimension tables around it. Those dimension tables will be further extended up to the requirement. There is a reason that it is called Snowflake schema. Now, next one. Next schema is Galaxy schema. Let me share the screen. This is fact constellation schema or galaxy schema, both are same. So here you are having fact table which are linked with dimensions like branch, time, item, location. Now, this particular, let's say, is other fact table. You are having two fact tables. So one more thing I would like to add here, that in flex star, you are having only single fact tables. In fact constellation or galaxy, you are having multiple dimension tables, and any dimension table can with any other dimension table or this fact table. Like these are two fact tables. Now here is dimension table location. This is location key in this fact table. This is location key, or let us say from location in this fact table. This is fact table for sales. This is for shipping. So location dimension here, location key should be there. It is not mentioned here. So it is linking to this location table, which is common to this both. Now this is best example. For example, item key. Item key is available in the sales also. Item key is available in the shipping fact table also. Both are linking to this item. Right. So and for example, here in sales, time key linking to this time dimension table. Shipping time key, which is also linking to this time. Fine. So any dimension table can be linked with any other dimension table, as well as, like let us say you are having, let us say, a shipper key, which is linking to this shipper dimension table. Now this shipper dimension table is also linked with this location dimension table. Fine. So you can have multiple fact tables here, and any dimension tables can be linked with any other dimension tables. Fine. That is why it is galaxy schema, because you are having multiple fact tables and all dimension tables are linked with or can be linked with other dimension table also. Again, it is not necessary that all should be linked with all dimension tables. Like branch is individual. It is not linked with any other fact table or any other dimension table. It is only linked with this single sales fact table. Okay, so up to this, all of you clear? Up to this, thank you so much for the responses. Dharmendra, Shivani, Rishma. All others, thank you so much for the response, Utvik. Thank you. Thank you, Ayush. Thank you, Rakshit, for the responses. Thank you, Shubh. Thank you, Abhishek. Great. And so I hope that everything is clear. Now, in the next lecture, we are going to understand this multiple dimension format and how you can analyze this multi-dimensional data, how it is useful. And this is the same thing that we have seen earlier. And different operations also we will see in the next lecture. Like this kind of operations you can perform on that multi-dimensional data, or cubes, you can say. And so all these operations also we will see in the next lecture. That is in the next week. And so thank you so much for attending this session, all of you. And for attendance, all are requested to please mention your enrollment numbers in the comment box. All of you, please